Hello, this is Brother Cromar from the Math Department, and this is a continuation of Lesson 14 dealing with inference for two means independent samples. And for Part 2, I'll be covering confidence intervals and checking requirements for independent samples. Let's review first other confidence intervals that you dealt with. The very first one you saw was one mean, standard deviation or sigma known, and we used the z-distribution for that. Okay, and our population standard deviation was known when we solved our confidence interval. But how realistic is our population standard deviation being known? Well, we found out later that it's not very realistic, so we dealt with one mean standard deviation unknown confidence interval, where we dealt with a t-distribution, and we estimated our population standard deviation, which is S, which is our sample standard deviation. Okay. So then we dealt with in lesson 13, which is matched pairs, and this is the formula for it, but notice how similar, if you remember the difference between these two formulas. Basically, a matched pairs is a one sample t of differences, where instead of x bar, we have d bar. We're using a t-distribution, but instead of s, we have s subscript d, which is the standard deviation of the differences. And n for matched pairs is the number of pairs in our sample. Okay, now we're dealing with independent samples. And so now it's a bigger formula where the point estimate is the differences between the two sample means, and then add and subtract a margin of error where we take something from the critical value from a t-distribution and use standard deviations and sample sizes from both samples, and everything to the right of the plus or minus sign is the margin of error. Okay. So, but we're going to be using software to calculate our confidence interval. So let's go through an example of this here. So going back to the problem that we dealt with reading practices with children, there were two different groups if you remember. Now instead of doing a hypothesis test, let's do a confidence interval. So starting with this sentence here, calculate and interpret a 95% confidence interval for the mean difference of the number of nights each week that the children participate in reading in the home between the two groups. Now this is the lower bound and the upper bound, and just going briefly to the output that I have from SPSS, which is similar to the output in Excel. This is where I would get it. It's under the equal variance is not assumed, just like Excel. This is SPSS, and this is my lower bound and my upper bound. Now if I switch the two, where I put the second group in before the first, I would have negative 0.987 and positive 0.149, but the confidence interval in essence is the same. You just have to keep track of what you put in as group 1 and what you put in as group 2. We decided is that we made group 1 the behavioral problems group and group 2 the general population group. Okay, so this is where I get our confidence interval, and so going back to the PowerPoint slide, can we tell if there is a difference between the two groups? Well, since 0 is in our confidence interval, we cannot detect a difference between the two groups. It can either be negative or positive. Because our confidence interval contains both negative and positive numbers, it can either be that group 1 is higher or group 2 is higher. We cannot tell the difference, so it's inconclusive here. So now let's go through the next example, the World Cup problem. But now, so going back to where group 1 is the control period and let group 2 represent days during the World Cup. Calculate and interpret a 99% confidence interval of the mean difference in the number of cardiovascular events between the two groups. Now you get I got the numbers similar location where its equal variance is not assumed. This is for a 99% confidence interval. And we interpret this, we're 99% confident that the mean difference is between these two numbers. Okay. Now, can we tell if there's a difference between the two time periods? Well, in this case, since 0 is in the confidence interval, there is a difference. Also, since it's negative numbers, it's group 1 minus group 2, it appears there's fewer cardiovascular problems or events during our control period versus World Cup. So those of us who watch sporting events need to be careful in terms of how we deal with that in our daily lives. Okay, so then lastly, what I'd like to do is let's checking requirements for independent samples. Now, before doing independent samples tests, whether it's a hypothesis test or confidence intervals, we have requirements. First, the samples are from simple random sampling. The samples are independent. I included that. That was not part of the online textbook, but I included that because you need independent samples. And then the distribution of sample means is normally distributed for each group. So for each group, we need to check that either the data are normally distributed, so we use QQ plots, or we check the sample sizes are large. Okay. For descriptive statistics for independent samples, we'll ask you to list the sample means and standard deviations from both samples, and then for graphs to have histograms for both groups. Okay. Or you can use box plots as well for both groups as well too. Now what I want to do is show you a couple of examples of where you can get these results here. Going to my software here. If for instance, here's an example where you can have two histograms, and I have it here stacked one on top of the other. You can also get means and standard deviations from both groups. This is dealing with this is the problem dealing with two groups, one with the children with developmental problems and those that don't. And so here's the two histograms here. Here's the mean and standard deviations from both groups here. You can also get QQ plots from both groups, and it appears by looking at this here that we have the theta is normally distributed. So when looking just at this alone, we can see that the distribution of sample means from both groups are normally distributed. We can also look at the sample sizes. If we look at the sample sizes, they're large, and so we can assume, because of the central limit theorem, that the sampling distributions from both groups are also normal as well too. Okay, and then here are some box plots as well. Okay, and that concludes part 2 of lesson 14 and concludes for independent samples.